Nothing fancy tonight. I'm in a little bit of a hurry, but I did want to answer Ellie's only question. I think this might be a new record for her, about synthetic substitution to find the zeros, or in this case, solve a polynomial equation. So I'm just going to work this one out from scratch, and I'm going to say that P, my last constant term, is, well, I'm not going to say, I'm just going to observe that it's 4, and its factors are plus or minus 1, plus or minus 2, and plus or minus 4. And Q, my leading coefficient, hooked up with the biggest term there, is only, Q is 2, so it's only got factors of plus or minus 1, plus or minus 2. Okay, so all of my possible rational zeros are plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 2 over 1, plus or minus 2 over 2, we've already covered with the 1, so I'm not really going to worry about that. Plus or minus 4 over 2, and we've already covered with 2, and plus or minus 4 should be my last possible rational pair of zeros. So these 8 possibilities are what I've got. Starts out as a cubic. Just double checking here, factoring by grouping definitely won't work. Doesn't recognize any other patterns. Sometimes it's good to see if you think, if you happen to notice the coefficients are 1, 3, 3, 1, you'd go, oh, Pascal's triangle. Maybe it's maybe it's a binomial raised to the 3rd power, but it's not. So these are my only possible rational zeros. Ellie said, I think, see if I remember this right from her email, she thought 1/2 worked. And double checking fractions is kind of annoying, but you got to do what you got to do. So 2, -5, -6, 4. And let's see, I will bring down the 2, multiply it by 1/2 and get 1. -5 plus 1 should give me -4. 1/2 times -4 should give me -2. -6 plus -2 gives me -8. 1/2 times -8 is -4. 4 plus -4 is 0. I agree with Ellie. So what we've just discovered is that another way to write this polynomial equation is x minus 1/2. Remember, if 1/2 works as a 0, that means x minus 1/2 is the corresponding factor. You always wind up switching the sign. Make that a little darker there, or 3D looking anyway. Okay, and the remaining factor, based on the coefficients down here, is 2x squared minus 4x minus 8. And this is still equal to 0. Now, let's see what we have here. I don't like leading coefficients that aren't 1 if there's a reasonable way to get rid of them. All of these are even, I noticed. So I'm going to factor a 2 out of these 3 terms. And just because I don't really like that fraction, I'm going to take the 2 I factor out of these 3 terms and distribute it to this term. Check out this mathemagic. It's like a vampire. I'm sucking the 2 out of this factor and giving it to this other one here. And then what's left is x squared minus 2x minus 4 equal to 0. Now, this factor, again, is our 0 of 1/2. That's what it relates to. Set this equal to 0, and we would get 1/2. If we set this other factor into the 0, equal to 0, well, first off, I don't see a good way to break it down. So I would need to pull out the quadratic formula. And the first thing I would see with the quadratic formula, if I try my b squared minus 4ac, well, that is -2 squared minus 4 times 1 times -4. Okay, so that is 4 plus 16, which is 20 if I've done that right. -4, yep. Okay, so that's what's under the radical in my quadratic formula. So when I fill in for the entire quadratic formula, I get that x is equal to -2 plus or minus the square root of 20 over 2 times 1. Now, there's no reason I couldn't have done the quadratic formula from this step. It had used a for 2 and b is -4 and c is -8. I just didn't want to. I like this. But you should get the same answer, okay? Or you would get answers that are twice as big, and when you factored a 2 out, it would be a little bit easier. But it should reduce to the same thing, which is 2 plus or minus 2 root 5 all over 2, which means this, if you factor a 2 out of the top, cancel that out with a 2 on the bottom, gets you that x is equal to 1 plus or minus root 5. So my zeros are x equals 1/2, x equals 2 minus root 5, and x equals 2 plus root 5. Assuming I haven't made any silly little mistakes, these should be the 3 zeros. Since none of them are complex, they are all x-intercepts as well as zeros, and they would be x-intercepts if we had to graph this. They're not pretty, but it looks to me like the math works. If you want to double check, plug in 1/2 for x, then plug in 2 minus root 5 for x, then plug in 2 plus root 5 for x, and see if you get 0. You're welcome to do that. As the old math books used to say, that proof is left to the reader. All right, hope this helps, and I will see you guys online tomorrow morning. Have a great night.